Now my dear students, we can see this question number 30. Lithium metal crystallizes in a body-centered cubic BCC crystal. If the length of the side of the unit cell of lithium is 351 picometer, the atomic radius of lithium will be. Here my dear students, BCC structure, you can see the formula in BCC. For BCC, you can see here there is a root 3 by 4 into A. Here there is a root 3 by 4 into A. A is the age of the unit cell and you can get the 351. So when you can multiply this, you can answer 151.8 picometer. You can get this answer when put the values. 351 is the age of the unit cell. Now you can get the question number 30, answer is A. Now we can see here question number 31. Here my dear students, in question number 31, copper crystallizes in a face-centered cubic lattice with a unit cell length of 361 picometer. What is the radius of copper atom in picometer? What is the formula of my dear students? Formula of FCC. Here FCC formula is R is equal to A upon 2 into root 2. So here A is the age length, it is a 361. So you can put here 361 upon 2 into root 2, and that's one you can get when you can solve this problem. You can get the 128 is the picometer. So you can see here this is a 128 is the picometer of question number 31. Now we can see here question number 32. Which of the following statement is not correct? Here my dear students, answer is C. This is not correct statement. Why? You can see here theory of this question. My dear students, 52% of unit cell, 52% of unit cell is occupied by atoms and 48% is empty. So here you can see the fraction of the total volume occupied by the atoms primitive cell is 4.48 of 48%, but it's a 48% is the empty, my dear students, in unit cell, and 52% on the occupied by the unit cell, by the atoms in unit cell. So it is not a correct answer. And when you can see the other options, molecular solids are generally volatile. Yes, the number of Brevis lattice in Bishop crystal can be categorized 14. You can see Brevis lattice is a 14 type. The number of carbon atoms in a unit cell of diamond is 8. We can already discuss these options also. Now we can see the question number 33. Here my dear students, he says what is this radius ratio, means what is the formula. So if you know the formula of the different lattices, simple, cubic, BCC and this FCC, then my dear students you can get the answer, and your answer is this, because we can solve the various type of questions by use these formulas. Here 1 upon 2 root 2a, in BCC you can use that root 3 by 4 upon a into a, and simple cubic half a. So my dear students, answer is question number 33a, because simply in this question want you know the formula or not. So my dear students, first of all you learn the formula, you know the formula and apply the formula. Now this question is also asked in NEET 2008. Now my dear students, we can go to the question number 34. Here the fraction of the total volume occupied by the atoms present in simple cubic is, that is my dear students, pi by 6. Here answer is D. Now we can go to the question number 35. Here this is the numerical problems, my dear students, and fractions of unoccupied sites in sodium chloride crystal, we want that. So first of all we can see here theory and formulas. Number 1, here we can see the molar volume, because here density is given. So, molar volume from picnometric density. Density is equal to, you know very well, mass upon volume. So, here that is the 2.165 into 10 to the power 3, that is the cubic meter. Now, we can see here second molar volume from here X-ray. Here density D is equal to m upon 2.178 10 to the power 3. Now, we can see the third one is the volume occupied. Volume occupied. When you can get the volume occupied, then you can get the volume unoccupied. Here m is a common, 10 to the power 3 is a common, here this comma is replaced, and 1 upon this 2.165 minus 1 upon 2.175 is percent in cubic meter. This is the volume occupied. Now, in the last, here in this question, fraction of unoccupied sites, then you can see here fraction of unoccupied sites, that equal to, my dear students, here we can see the 0.013 into 10 to the power minus 3 divided by, these are divided by, here when 2.165 minus 2.175, then you can get that 0.013 into 10 to the power minus 3 divided by this whole means 2.165 multiplied by 2.175 upon m into 10 to the power minus 3 upon 2.165. And my dear students, you can get the, when solve this problem, you can get the 5.96 into 10 to the power minus 3, and this is the fraction of unoccupied sites. So, you can go to the question number 35, answer is D, and this question is asked in NEET 2003. First of all, we can get the volume, molar volume of picnometric density in X-ray, and then volume occupied you can get, and fraction of unoccupied, then minus and get the this, put the values and get the answer. Now, my dear students, we can go to the question number 36. Here question number 36, the age length of a 100 cubic, it is a very simple question, is 508 picometer. Okay, if the radius of the cation is 110 picometer, the radius of the anion is formula. Here, my dear students, in FCC. Here FCC length of unit cell, that equal to A, and that A is equal to cation plus twice R diagonally and plus anion. So, my dear students, you can also call that equal to A is equal to 2R plus 2R, and A is the, here when we can put the values here, A is equal to 2R plus 2R, put the values of A, that is 508, and here you can put the values of cations. These values of cations are the 50, cation values 110. So, you can put the cations into 110 plus 2R means 508, 220 plus 2R means 2R is equal to 508 minus 220, 2R is equal to that, 2R is equal to 508 minus 220 means that equal to 288, and when R is equal to 288 divided by 2, you can get the 1 44 picometer. And my dear student, this is the answer. Question number 36, you can get the answer A. Now we can see the question number 37. Iron exhibit BCC structure at room temperature above 900 degrees Celsius. It transforms to FCC structures. The ratio of density of iron at room temperature to that at 900 degrees Celsius. Now we can get the formulas. Which formula, my dear students, you can use, and this question is asked in NEET 2018. Here, my dear students, for BCC lattice, here Z is equal to 2 and A is equal to 4R upon root 3. Now we can take the FCC lattice. Here FCC lattice, Z is equal to 2 and A is equal to 2 into 2R. Now my dear students, we can see here formula D RT upon density room temperature and density at 900 degrees Celsius, and density at room temperature. So that is, my dear students, you can divide it by Z M upon Na Avogadro number into A ki power q. This is a BCC, for BCC, and now we divided by the Z into M upon Na into A cube, and this is for FCC. So my dear students, if you put the values, then you can get that 2 upon 4 into 2 root 2R upon 4R upon root 3, and that equal to q, and that equal to, my dear students, 3 root 3 upon 4 root 2. You solve these problems and you can get the answer, density ratio 3 root 3 upon 4 root 2. This is the answer of question number 37. C is the answer. So my dear students, you can put the only values of Z. Z is different, Z is common, it is a cancelled, M is comma, only AQ, here AQ is different. So you can put the values of here AQ, and A is 4R upon root 3. Here you can put the values of FCC of AQ, it is that equal to 2 into 2R, because in FCC lattice here Z is also difference, that is, my dear students, it is a 4, not 2, you can take the 4. So we can take here 4, because after the solution we can here take this 4, here 4 2 upon 4, here 2 is the Z upon 4, here 2 upon 4, and when A cube and A cube, you can cube ki power 2 root 2R cube you can put here, and that is A cube for BCC, that is 4R upon root 4R upon cube root ka cube you can put here, and by solve these problems you can see you get the 3 root 3 upon 4 into root 2. So you can get the answer. C is the correct answer of this question. Now my dear students, this question is also asked in NEET 2018. Now we can go to the question number 38. Here, my dear students, question number 38, lithium has a BCC structure, its density is 530 kilogram per cubic meter and its atomic mass is 6.94 grams per mole. Calculate the age length of unit cell of lithium metals. My dear students, here we can use the formula and calculate the age length. Here for the BCC, my dear students, Z is equal to 2 and here Z is equal to 2, because here lithium has a BCC structure, and density, he gave the density 530 kilogram. My dear students, this density is converted into grams per cubic centimeter, here grams per cubic meter. You can convert the grams 530 into 1000 upon 1 into 100 cubic centimeter. So, my dear students, you can get the 0.53 grams per cubic centimeter. Now, we can see here, this is the density. Now, we can see here Na. Here Na is also given, Avogadro numbers, that is 6.02 10 to the power 23. Now, he can give us atomic mass also, and atomic mass is the 6.94 gram per mole, and these are the values which are given in our numerical. Now, my dear students, he want to calculate the age length of the unit cell, because their density is given. So, we can put first of all formula relationship between density, that equal to Z into atomic mass upon Na, Avogadro number, multiplied by AQ. Here, my dear students, you can put the values. Here density, here AQ you can, because here age length is, you can determine the age length, that is why AQ you can get Z into atomic mass upon Na into density. Now, you can put the values. Z is equal to 2 for BCC structure, Z is equal to 2. Atomic mass is given, that is 6.94 and given in grams. So, we can convert this density kilogram cubic meter into grams. Here divided by Na. Na is the, my dear students, 6.02 into 10 to the power 23 multiplied by the density, that is 0.53, you get the AQ, and AQ is the, my dear students, that is 43.5 into 10 to the power minus 34. Now, when you can get the A, then cube root of these values 43.5 into 10 to the power minus 34, then you can get the A is equal to 352 into 10 to the power minus 10 centimeter, or you can get the 352 picometer. So, my dear students, this question is asked in NEET 2016 in first paper. Here you can see the calculation is lengthy, but you can solve the question when you can put the values and you can solve it. Now, we can see the answer is 352 for this question. Question number 38, answer is D. Now, my dear students, we can go to the question number 39. Now, my dear students, question number 39, a metal has a FCC lattice. The edge length of the unit cell is 404 picometer. The density of the metal is 2.72 grams per cubic centimeter. The molar mass of the metal is. This question is also asked in NEET 2003. Here, my dear students, you can, first of all, you can write the formula to calculate this. We can write the formula, density is equal to Z into molar mass or atomic mass upon Avogadro number into age of the unit cell. Here we can see here Z is for FCC structure, that is 4, and this Na is given, that is 6.02 into 10 to the power 23. Here A, age of the length, it is also given A, that equal to 404 picometer. My dear students, this age is converted into picometers, converted to centimeter, 404 into 10 to the power minus 10 centimeter, first of all. Now, we can see here this is not converted. After this, we can get this density. A density is given, that equal to 2.72 grams per cubic centimeter. So, my dear students, you can convert this picometer into centimeter, because here density is given in cubic centimeter. Now we can see here, we can put these values and get this m. First of all, we can put the values d. For d you can put the 2.72 into that equal to z, z4, m is calculated and n is 6.02 into 10 to the power 23 and a is the 404 into 10 to the power minus 10 की power 3. Now we can solve this problem. Here m is equal to 6.02 into 10 to the power 23 into 404 into 10 to the power minus 10 की power 3 and multiply by this value 2.72 and this whole value is divided by this 4 because 4 is multiplied by m. So my dear students, you can get the molar mass m that equal to 27 gram, and this is the answer when you solve this question, and you can get the answer 27 gram. And in this solve only multiplication is there and divide is there. Multiply this all quantity 10 to the power 23 and 10 to the power minus 30. 10 to the minus 10 and 10 to the minus 30 you can cancel with each other, and finally you can get this quantity and multiply and get the answer. Answer is, my dear students, 27 gram. Now we can see here question number 40. Here in question number 40, CSBr crystallizes in a body-centered cubic lattice. The unit cell length is 436.6 picometer. Given that the atomic mass of cesium that equal to 133 and that of bromine that equal to 80 AMU and Avogadro number being 6.02 into 10 to the power 23 per mole. The density of CSBr. Here, my dear students, what is the formula? Here same formula is apply. Formula is this density is equal to Z into molar mass upon Avogadro number Na into A's length A cube. Now here what is the given in the question? Here for this BCC, here BCC is given. For BCC, my dear students, Z is equal to 2. Here m is the molar mass, and here m is the molar mass is given. Here CS atomic mass 133 plus Br 80. So both are plus and you can get the 213, it is a molar mass. Now we can see Na. Na is also given in the numerical, that is 6.02 into 10 to the power 23. Now we can see here A for H. A is also given to you, that is 436.6 picometer. Now it is converted into centimeter, 436.6 into 10 to the power minus 10 centimeter. And my dear students, you can put these values in this formula and you can get the density. Now we can put the Z2 molar mass 213 divided by here Na 6.02 10 to the power 23 into A 436.6 into 10 to the power minus 10 की power 3, and you can get the density, and this density is equal to, my dear students, when you can solve this problem and you can get the 4.25 grams per cubic centimeter. So this is your answer, and this answer is given in option A. So you can go to the option A, question number 40. This question is asked in 2006 NEET exam. Answer is A. Now my dear students, we can go to the question number 41. An element atomic mass 100 gram per mole having BCC structure has unit cell age 400 picometer. The density of the element is. Here my dear students, formula is same. You can use the same formula. Density that equal to Z into m upon Na into A की power q. My dear students, what is the values given in this question. Here BCC structure is present. So, for BCC Z is equal to 2 you can take, and molar mass M, it is 100 gram per mole. Now, A, that is 400 picometer. So, my dear students, you can convert its centimeter, 400 into 10 to the power minus 10 centimeter, you can convert it. Now, Na is not given, but you know the values of Na, that equal to 6.02 10 to the power 23. Now, my dear students, you can put these values in this formula and get the answer. 2 multiplied by the molar mass, that equal to 100 upon Na, 6.02 10 to the power 23, multiplied by A cube. A is the 400 into 10 to the power minus 10 की power 3. So, my dear students, you can calculate the density of this question at 200, and these are multiplied by with each other, 400 10 minus 10. So, my dear students, you can get the density that equal to 5.188 grams per cubic centimeter, and this is answer, my dear students, and you can get this answer in question number 41. You can get the D option is the correct answer. Now, we can see the question number 42. Formula of nickel oxide with metal deficiency defect and its crystal is Ni.98O. The crystal contains Ni plus 2 and Ni plus 3 ions. The fraction of nickel existing as Ni plus 2 ions in the crystal is. Here, my dear students, I give you concept and formulas for this question. Here you can see here Ni.98O. It means, what is the ratio? Here, my dear students, you can see the 98 is to 100 ratio is present. Here you can see the in this 98%, 98 is the ratio of nickel, and in this nickel, my dear students, Ni plus 2 ions and Ni plus 3 ions both are present. So, you can see here first of all Ni plus 2 ions, it take as a X plus ions, because in question the fraction of nickel existing as Ni plus 2 ions, you can take the Ni plus 2 ions that equal to X. Now, we can see here Ni plus 3 ions that equal to 98 is total minus X, then you can get the nickel plus 3 ions. Now, in Ni plus 3 ions, my dear students, here you can see this is the charge, plus 3 charge is also present, 3 into 98 minus X plus 2X. Here 2 charge is present on plus 2 in nickel, 2X that equal to 2 into 100. My dear students, here minus 2 charge present in oxide. In oxide minus 2 charge is present. So, 2 into 100. Now, we can solve this problem. 244 minus X plus 2X and that equal to 200. Now, we can see here 294, here this is the 294 minus X plus 2X is equal to 200. Here, my dear students, what is the X? Here, when you can see the X is equal to 94, because here you can calculate this X, this is the 94, 294, because 3 multiplied by 198 multiplied by 3, you can get the 294. So, this is a 294 is here. minus 3x, 3 multiplied by x plus 2x, 200. So, my dear students, when you can see the values, here 2x and 3x are cancelled with each other. So, you can get the only here you can get the only minus x here, minus x, that equal to 294 here, 200 minus 294 minus x is equal to 94 minus 94, and both are cancelled with each other. So, you can get the x is equal to 94. Now, we can get the x is equal to 94. Now, we can get the percentage of Ni plus 2, that equal to 94 x, because here x is the Ni plus 2, we can take it earlier. So, 94 upon total 98% nickel. So, this is the 98, 94 upon 98 and multiply by the 100. So, my dear students, you can get the, that is 96% Ni plus 2 are present, or you can say the 0.96. So, your answer is A, question number 42, and remaining is the Ni plus 3. So, Ni plus 3 is the, that equal to 4%. Now, we can go to the question number 43. Here the correct statement regarding defects in crystalline solid is, my dear students, Frankel defect is a delocalization effect, and this is the correct statement about this. Frankel defect is a delocalization defect, because in Frankel defects here one of cation or anion is go to the another vacant space. It is called Frankel defects. So, this is the correct statement. Now, we can see the question number 44. The appearance of color in solid alkali metal halide is generally due to, my dear students, F center. Here F center is present. What is the F center, my dear students? When any crystals, for example, Na plus, Cl minus, here Cl minus, here this is the back end, here this is the back end, or you can see here back end position is present here, here Na plus, here Cl minus, here Cl minus is present, or here Na plus is present. So, we can see here when electron is come in this interstitial back end species, then it is called F center. So, my dear students, it is a theory and concept which is given by me, theory and concept. So, this is called, my dear, F center, and you can get this F center, and color of the alkali, solid alkali metal is due to these electrons, because these electrons accept energy and emit another energy. So, you can go to the answer B, question number 44. Now, we can see the question number 45. Schottky defect in crystal is observed when, answer is D, equal number of cations C plus or anions A minus are missing, that those are the equal numbers. So, you can call this Schottky effect. For example, if you Na plus, Cl minus, Na plus are present, here Cl minus, Na plus, Cl minus is present, Na plus, Cl minus, Na plus is present, here Cl minus, Na plus and Cl minus is present. Then we can see here when one of Cl minus equal number of here Cl minus is absent, and here you can see the Na plus is absent, equal number of cation and anions are absent. This type of defects is called, this type of defect is called Schottky defect. So, it is called Schottky defect. So, my dear students, we can solve all the questions which are coming in your solid state topic, my dear students. I give you all the concepts, formulas which are used in this topic. I hope when you see this topic and learn the formulas, you can solve the questions which are coming in your exam. Thank you.